Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 21 to 24 of the June 2015 Algebra I Common Core NYS Regents exam. All right, let's take a look at problem 21. It reads, a student is asked to solve the equation 4 times the quantity 3x minus 1 squared minus 17 equals 83. The student's solution to the problem starts as 4 times the quantity 3x minus 1 squared equals 100. And then the next step is the quantity 3x minus 1 squared equals 25. Obviously, the student divided both sides by 4. A correct next step in the solution of the problem is, so that's the question. Now, one thing you want to note is that whenever you take the square root of a square, when you're solving an equation, you have to introduce a plus or minus in one side of the equation or the other, all right? The steps we're going to use to solve this problem are as follows. We are going to write down the last step the student wrote, and then we'll advance to the next step with the goal of isolating x. That's a long-term goal, but we'll just carry on to the next step and then see which of these options matches the simplified form of our next step, okay? So we have 3x minus 1 squared equals 25. Remember, the goal is to solve. We want to isolate y, okay? So in order to isolate y, we have to get rid of the square, the -1, and then the 3, all right? But they just want us to do one step, just the next step. The next step is to get rid of the square. So what is the opposite of square? Square root, right? So you take the square root of both sides of the equation, and then we have 3x minus 1 equals 5. Okay? Now, we're missing something. Do you know what that is? Remember, we talked about this earlier to note that anytime you take the square root of a square, you have to introduce what? A plus or minus, okay? So you can put it in front of this quantity on the left side, or you can place it in front of the 5, okay? So let's just place it here, plus or minus. So that's the next step. So let's see what option matches this step. Our answer is option number 1. All right, let's take a look at problem 22. It reads, a pattern of blocks is shown below. So we have this pattern here, term 1, 2, 3, 4. So the question is, if the pattern of blocks continues, which formulas could be used to determine the number of blocks in the nth term? So note here that you could have more than one solution, all right, as indicated in the responses here. Now, one thing you want to note is that a pattern of blocks, if you see problems like this is basically a visual way of representing a table of values. Okay, it could be a table of values. This could represent a function, a recursive definition. It could be also a way of representing a graph. All right. Okay, the steps to solve this problem are as follows. We're going to express this pattern of blocks as an input-output table or XY table. Then we're going to test each of these formulas to see which yields exactly the same output as the input-output table. All right, so let's go ahead and do that. For term 1, we just count the number of blocks. Term 1, we have 2 blocks. Term 2, we have 2 plus 4, 6 blocks. And then term 3, we have 4 plus 4, that's 10 blocks. You see a pattern here, right? They keep adding 4 every single time. So these 4 blocks were added on to term 1 to get this one right here. And then here, another 4 blocks was added on to get this term right here. And then another 4 was inserted, and then this is 14. So you notice that the growth rate here is 4. So keep that in mind. Now let's organize this in a way that's easy to work with. We're going to make an input-output table. So let's put it down here. So we have 4 ins and 4 outs. So we're going to call this n, and this is an, okay? So for when you have for our first term, when n was 1, we had an output of 2. When n was 2, for the second one, output of 6. When n was 3, output of 10. When n is 4, output of 14. So this is just like an XY table, but we are just using a different notation here. We're using n and an. N is like your x, an is like your y. If you do not like n and an, you can always use x and y by all means, okay? I'm just trying to keep it consistent with the notation that we have in our alternatives. Now the goal is to test each of these formulas with this n input values, and we want to see which would generate this exact list of output values. Okay, now let's test option number 1. Let's test 1. 1 is an equals n plus 4. So to test it, we just simply create a new input-output table and then just compute the outputs. As soon as we see any discrepancy, we can just stop there. No need to continue wasting time. All right, so we have a, and here an is n plus 4. All right, let's start with 1. So we have 1. A1 is going to be 1 plus 4. You plug 1 in there, and then your output is going to be 5. Is that the output here when n was 1? The answer is no. 5 is not equal to 2. 5 is not equal to 2, so that's a fail right there. Okay, so what does that mean? That means that table 1 does not work. What do? We advance to the next one, right? Now let's test option 2. Option 2 is the formula, actually is the recursive definition. A1 is 2, and an equals an minus 1 plus 4. All right, let's go ahead and generate the table using this recursive definition here. So let's do this. We have n, and then we have an. An is defined as an minus 1 plus 4. Now, what on earth is an minus 1? A sub n minus 1 is simply the term before an. Okay, that's what recursive definition is. If a term depends on the term before it for its definition. We're starting from 1. What is 1? A1. A1 is already given to us. A1 is 2. Does that match what we have there? That's perfect. That checks out. Let's move on to the next output when n is 2. Okay? When n is 2, what do we desire? If we can get 6, then that's good. If not, then we have a problem. So when n is 2, we're going to have a2 is going to be a2 minus 1 plus 4. a2 minus 1 is a1 plus 4. Okay? A1, what is A1? A1 is 2, so 2 plus 4 is 6. Is that what we want? That's exactly what we want. That's a check, looking good here. Next one is n equals 3. We have to test them all. We can take anything for granted. A3 is going to be A3 minus 1 plus 4. What is A3 minus 1? That's A2 plus 4. What is A2? A2 is a term before it, which is 6. 6 plus 4, which is 10. You see a pattern here? We keep increasing by 4 every single time. Isn't that the pattern we saw when we were counting the number of blocks in our table? So that's exactly what's happening here. Let's do the last one. A4. Can you predict what A4 is going to be? It's going to be 14, right? Let me show you the steps. A4 minus 1 plus 4, which is A3 plus 4. A3 is a term before A4, which is 10 plus 4, 14. Excellent. This is an exact match. Okay, all our outputs match. So option 2 is good. We done? No, we have to, well, we can actually we can actually determine that the answer is 3. How so? Because that's the only option that has 2 and does not have 1. Because we know 1 already failed, and the only other option that has 2 is option 3. All right? So that's the answer. But let's go ahead and work it out. Okay, I want to show you option 3 and just show you for certainty that option 3 is going to work also. All right, so I've divvied up my workspace. Let's go ahead and test option 3. We should get the same output. So test 3. Formula 3 is an equals 4n minus 2. So let's make our table of values. This is not necessary. I'm just trying to show you for certainty that our conclusions that we were able to derive is actually true. So n and an is 4n minus 2. So we test 1. Hopefully we get 2, or else there's going to be a big problem. A1 is 4 times 1 minus 2. That's 4 times 1 is 4, minus 2 is 2. Check, like we expected. Next test is n equals 3. Let's plug that in. When n is 2. And the next one, A2 is going to be 4 times 2 minus 1. 4 times 2 is 8. Minus 2. And minus 2. 8 minus 2 is 6. That checks out also. Next term, n is equal to 3. So when n is equal to 3, A3 is going to be 4 times 3 minus 2. 4 times 3 is 12, minus 2 is 10. That matches this output right here. That's a check. Last but not the least is n equals 4, the fourth term. When n is 4, we have A4 is going to be 4 times 4 minus 2. 4 times 4 is 16, minus 2 is 14. That works perfectly. So we see that option 3 is also good. So our answer is number 3. All right, the reason I went over this on the next Regents exam, it could look different. So I want to make sure that you know how to test every single formulation. All right. All right, let's take a look at problem 23. It reads, what are the solutions to the equation x squared minus 8x equals 24? Now, one quick reminder is that when you're using the quadratic formula, always use parentheses, okay? When you use parentheses, it helps keep you avoid errors, okay? So just keep that in mind. All right, so the steps we're going to follow to solve this problem. First of all, we want to rewrite our equation in standard form. That's really important. Then we'll write down the quadratic formula. It's always good to have it before our eyes so we don't make any mistakes. And then we're going to find A, B, and C, substitute it into the quadratic formula, and evaluate. Okay? So the equation quadratic we have is x squared minus 8x equals 24. Standard form requires it to be equal to 0, with each term in order of decreasing degrees from left to right. To accomplish that, we subtract 24 from both sides. That yields x squared minus 8x minus 24 equals 0. Now, why did I bother factoring? How do I know that this is a quadratic formula problem? Well, if you see square roots, radicals in your options, don't try factoring, because that indicates that your polynomial is prime. It is not factorable, okay? When you see square roots or i's, imaginary numbers, in your options, then just go right to the quadratic formula, okay? All right, so what is the quadratic formula? Let's go ahead and write this here. It's always good to have it before your eyes so you don't make any mistakes in your substitution. Now, when you're writing over 2a, remember you're dividing the entire expression on top by 2a, not just the radical component, not just the square root part, okay? Now, we have that, so we know that a is the coefficient of x squared, a is 1, B is negative 8. Now, whenever any of the letters is negative, you have to proceed with extreme care because those negatives could introduce errors, all right? So B is negative, which means we have to be cautious here, and C is negative also. So you have to be really cautious because we have two negative numbers to work with. Okay, so let's input this into the quadratic formula. So x is going to be negative 8 plus or minus the square root of b squared minus 4ac. Remember the entire expression, okay? The entire expression over 2a, 2 times 1. Now, what did I use here that we talked about earlier? I used parentheses for my substitution. That's a very good practice that helps you avoid errors with signs, okay? Now, let's go ahead and simplify this carefully. We are going to now have minus times minus is plus, so we have 8. 8 plus or minus, 8 plus or minus the square root of, you can plug this entire expression in your calculator, but let me just work it out for you. 8 times 8 is 64, minus times minus is plus, 4 times 24 is 96, divided by 2. So this is going to become, we can now separate the division, okay? So we have 8 over 2 plus or minus 96 plus 64, let's see, 401, 160 over 2. Okay, now let's reduce 160. So we have the square root of 160. I just want to extract primes, okay? Take out 2, 280. Take out another 2, 40. Take out another 2, 20. Take out another 2. My 2 is looking weird here. Let's go ahead and fix that. Sorry about it. Okay, so take out another 2. We have 10. And take out the last 2. We have 5. Okay, so in order for you to factor out any squares, they have to repeat, right? So 2 times 2 is a square. What is the square root of 2 times 2? 2. And you have another 2 times 2 here. What is the square root of 2 times 2? It's 2. And then you're left with 2 times 5. They are not squares, so they stay behind, okay? So this 2 and this 2 come out as 4, and you're left with 2 times 5, which is 10. So the reduced form of root 160 is 4 rad 10. Okay, so this becomes 8 over 2, which is 4, plus or minus 4 rad 10 over 2. Now we can divide this. 2 goes into itself once, 2 goes here twice. Your final answer is going to be 4 plus or minus 2 rad 10. 4 plus or minus 2 rad 10. Answer is option number 1. All right, let's take a look at number 24, the last one in this review installment. It reads, Natasha is planning a school celebration and wants to have live music and food for everyone who attends. She has found a band that will charge $750 and the caterer who will provide snacks and drinks for $225 per person. If her goal is to keep the average cost per person between $275 and $325, how many people P must attend? So a quick reminder is that anytime you reciprocate an inequality, it reverses the direction of the inequality. It's just like you're multiplying or dividing by negative. You know how it switches the order of the inequality symbol? The same procedure applies to reciprocation, all right? Steps are as follows. First of all, we're going to declare our variables. Actually, we have just one variable here. And then we'll set up our cost equations and the compound inequality. All right. And then after setting up our compound inequality, we have a bounded situation here. We will proceed to isolate P in the middle, and that will be our final answer, as we can see in the options provided. Okay, so let's start with our declaration. Let P, it's already done here, but it's good practice to always do that. Let P equals the number of people that must attend. Okay, number of people that must attend. Okay, so now what is the total cost for P people to attend? Total cost is basically the base cost per person times plus the base cost plus, let's write that down, base cost, which is a fixed price regardless of how many people attend, plus the cost for P persons, because that's the amount of people that are going to attend. We said P, right? All right, so let's go ahead and translate this out. So the base cost is $750. See, if one person attends or 10 people attend, it doesn't affect the charge that the band receives. That's fixed. Okay, 750 is fixed regardless of how many people attend. But the catering charges is dependent on the number of people. See, 225 per person. Okay, so the total cost for P persons is the unit cost times the number of people. We talked about this earlier in our previous installments of this review series. So it's going to be unit cost of 225 times the number of people, which is P. So there goes your total cost. Okay, now let's figure out our minimum cost. Minimum cost is the lowest price per person. Okay, the lowest price per person that she's willing to accept. And the lowest price per person, lowest cost per person is $275. That's the unit price, the lowest unit price. So the total minimum cost is going to be the unit price times the number of people, P. Okay, so that's your minimum cost. Now, can you use this procedure to determine the maximum cost? You just take a look at the second value here, the upper value. This is the highest cost per person she's willing to accept. So we multiply that maximum unit cost times what? Times the number of people, P. So you have your minimum cost, you have your maximum cost, and this is your total cost right here. Okay? So how many people must attend? So now we're still in step 2. We're going to set up our compound inequality. Okay? So this is a compound inequality we're setting up here. All right, so can you imagine what the compound inequality is? Well, it is as follows. We have the minimum cost is kind of like the floor. Okay, the minimum cost has to be less than the total cost. And the total cost has to be less than the maximum. That's kind of like the ceiling, right? Maximum cost. So it has to reside somewhere between these two values, between the minimum and the maximum. All right, so what is our minimum cost? Our minimum cost is 275p, okay? $2.75 times p people. Our total cost is the base cost of 750 for the band. For us, 225 that a caterer charges for p persons. Maximum cost is 325 unit cost times the number of people, P. Now we have our compound inequality. The goal here is to get P isolated, and that will be that. Okay, we want to get P in the center. Okay, now first thing we can do is make it look simpler. Now this equation is a little bit complex because of the decimals. If at all possible, you want to avoid working with decimals because it complicates things. Now, how can we get rid of the decimal? The highest number of decimals we have here is 2, so we'll multiply 100 with 2 zeros, multiply the entire inequality by 100. Now, what does that do? Multiplying by 100 causes the decimal point to move 2 places to the right, okay? So 2.75 becomes 275p. The inequality remains unchanged since you're multiplying by a positive number. 750, do not forget, gets multiplied by 100 also. So that becomes 75,000. This has a decimal point 2 places to the right, 225p. And this one 2 places to the right, 325p. Okay, what have we accomplished thus far? We have eliminated the decimals. Now this looks prettier, okay? Now next thing we're going to do, we'll go ahead and subtract 225p to the left and to the right. So we'll subtract 225p. This is a complex inequality. So anything you do to one side of the inequality, you have to do to the other two sides, okay? So we have that subtraction there. So we have 50p is less than 775,000, and that's less than 100p. Now, the beauty of this step is that we have the p's on the exterior. Now I can simply divide the entire inequality by p to make it end up in the middle. Okay? So let's go ahead and do that. Divide the entire equation by p. Divide by p. Divide by p. Divide by p. Now, there are other ways you can solve this inequality. This is just one way, but whichever way you do it, you still end up with the same answer. Okay? All right, so divide everything by p. We're going to have 50 as less than 75,000 over p, and that's less than 100. All right? Now, the next step is simply going to reciprocate. Okay, reciprocate the entire inequality. So raise this entire inequality to the negative 1 power. So if we reciprocate, we're going to end up with 1. Let me split my work. So, okay, I can do that. So 1 over 50. And this becomes p over 75,000. And then this becomes 1 over 100. Now you notice I left out the inequality. Well, I have a reason for doing that. Anytime you reciprocate your inequalities, as though you're multiplying by negative 100. All right. So I reciprocated the entire thing. So what's going to happen with the inequality? It switches. You have to switch it. Anytime you reciprocate an inequality, it switches the inequality symbol. All right, almost there. To finish it off, we just need to get p by itself in the middle. So we'll multiply the entire equation by what? The denominator value, which is 75,000. Multiply that through, and that gives us, so distribute it to every single term, 75,000 over 50. In the middle, it cancels out. Ooh, it's not equal to, it's greater. So it's greater. And then we have p. P is greater than now 75,000 over 100. Right there. Okay, so just reduce it. On the left side is divides, that divides out. And then 5 goes here once. 5 goes into 7,500. Well, 5 goes into 7 once. Carry 2, 5, 0, 0, 1,500. And then over here, just simply cancel out the zeros, and you have 750. Okay, so let's go ahead and rewrite that. We have 1500 is greater than p is greater than 750. And if you want to order it from least to greatest, you can rewrite this as 750 is less than p, and p is less than 1500. All right, so that's your final answer. Answer is option number 4. Okay, so that's that. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found this tutorial beneficial to you, do give us a thumbs up. We'll appreciate your positive feedback. Do not forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions about any of these problems or any questions on the Algebra I Common Core exam, please include your question in the comment section below, and we'll be glad to address it as soon as possible. Don't forget to take our interactive practice tests. We'll be glad to assist you with preparation for the test using that tool. More quizzes can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day.